In this video I'm just going to run through how to answer the parts of question 1 in the week 7 quiz that required you to use Excel. So the first question was part B of question 1, where you were asked to run a regression analysis on this data, with y being the dependent variable and these 4 explanatory variables. So as usual, we'll go to data, then data analysis, choose the regression tool. You now need to select the y values, the values of the dependent variable. There they are there. The x values, so I'm just selecting all of the cells containing those 4 explanatory variables. I've included headings, so I better tick labels. And you're specifically asked in this question to output it starting in this cell here. And hit OK, and OK again, and the regression analysis is complete. So that was B. A little bit further on in G, you are asked to incorporate the estimated values of y from the fitted regression line into this worksheet. So we're trying to use the regression model to show the y value, the expected value of y that it produces. And so that will involve us using the coefficients that have been estimated down here and applying them to the specific values of the explanatory variables that are shown here. In the first row, which is the first element in the sample, my formula is going to be equals the intercept term B1 plus the coefficient of the explanatory variable t times the actual value of t for this element, plus B3, the coefficient of the RG explanatory variable times its value, plus this coefficient times its value, plus the final coefficient times its value for this element which is lurking under there. I'll hit enter. Now I want to copy this formula down, so I need to put some dollar signs in some of these, in front of some of these columns or row numbers. And just thinking about what I want to do, I want to drag it down across different rows, but as I do so I want it always to refer to these particular coefficient values. So I want to lock in their rows, and these are all in I, so I need to lock in with a dollar sign and an absolute reference. The 18, then the 19, then the 20, the 21, and the 22. I don't need to put dollar signs anywhere else because I want all the current references on row, or in row 2, to float as I drag this formula down. So I'm going to hit enter, drag it down just one cell so I can check it. I'll double click. It does seem to be referring to all the right coefficients here. It seems to be referring to all the right explanatory variable values here. So I think I got the formula right, and now I will just drag that all the way down this column. And I don't like that font size, so I think I'll just change it to be consistent with the others. Full marks require this to be done, of course. Now, part J is asking you some information about hypothesis testing, specifically the hypothesis test that is being considered by these values down here. And the first one just says, how do you know it's a two-tailed test? That's because the alternative hypothesis is not equal to. Then the second part says, show how the indicated test statistic has been calculated. Well, I'm going to do that in a little bit of space up here. The test statistic for this hypothesis is the beta value that we estimated minus our hypothesized parameter, which is in this hypothesis test 0, and then divided by the standard error of B5. So that's kind of a representation, but in Excel I'm just going to put those numbers in. So to start a formula equals, open a bracket, the estimate of B5 is this one down here. In fact, I didn't really need the bracket because subtracting 0 is trivial. And then I'm going to divide that by the standard error of B5, which is this one here. And that value that I've just calculated corresponds to this one down here, which is what we were asked to show. Part 3 says what Excel function could be used to derive the indicated p-value, so this one down here. Remembering this is a two-tailed test, to get the p-value we want to calculate a probability from the t-distribution given this value of the test statistic. So to do that, I'm going to use the t-dist function. It's showing me what arguments it needs here. So x is the test statistic, so that's this one. The degrees of freedom are the number of observations, 48, minus the regression coefficients that we're estimating, of which there are 5. So 48 minus 5 is 43, and that should correspond to the degrees of freedom that are shown for the residual down here, which it does. And then finally, because our alternative hypothesis is two-tailed, we need to choose the final argument as 2. And there's the p-value, which corresponds to the one down here. I'll leave the answer to 4 for written solutions. And then the final one, part of question 1, which required Excel use, is part L. It says provide a 99% confidence interval for B5. So I'll do this. One way to do this would just be to rerun the regression, and in doing so, select as an option that we want to have a 99% confidence interval. I might just do that last, but right now I'll just show you how you could take a more manual approach to calculate this 99% confidence interval. So the interval is calculated as our estimate of B5 plus or minus a critical value from the t-distribution times the standard error of B5. Now we've got this directly below. It's this value. We've got the standard error of B5. It's this one below. So all we need to do to calculate this confidence interval is to find the critical value for a 99% confidence interval. Critical value means that we're wanting to go from a known probability to a value in the t-distribution. So that means we need to use the t-in function. It requires us to give it a probability as the first argument. This is the probability that's going to be left out in the tails, which for a 99% confidence interval is 0.01. The degrees of freedom are the same as we discussed previously, so 43. And I will hit enter. So that's the TC up here. We now have all the 3 parts that we need to construct this confidence interval. The lower value is going to be equal to the coefficient minus TC, the critical value from the t-distribution times the standard error of B5. Now, I'm just thinking I might have referred to these cells a little bit earlier when I was talking about this confidence interval, but it's actually these ones that we need. And hit enter there, and then for the upper end of this interval, well, because I'm lazy, I might just change this one. Well, it's an exercise for you to try and work out where you'd have to put dollar signs in this to drag it down and have it, with a minor adjustment, work for the one below. Let me see. For this one here, I want to keep the 22 fixed. In fact, it's all the rows that I want to keep fixed. So I will now drag this down, and the only difference for the upper end of this confidence interval is to change that to plus. Right, so there's my answers. Calculated in a manual way. I'm going to copy them here. So I've highlighted them. I'm going to press Control C, and then I'm going to paste them. Excel will allow me to do this. I'm going to paste them as special. Oh, this is all going wrong. Let me try that one more time. So I've got the values up here. Control C. I'm going to come down here and paste special. Now I want to paste the values only because there are formulas sitting in these cells up here, and if I paste them as a normal paste, it will copy the formulas and try to find new cells to calculate the values. In fact, look what happens if I do this. I get some numbers that are completely different to what I started with. But if I copy these again, come down here and paste special values, it gives me exactly the values back up here. And if I click on these cells, in fact, you can see here, there's no longer any formula there. It's just giving me the result only. Now I've put them out here just so that when I run the regression again, which is the final thing I'm going to do, I'll get a 99% confidence interval given to me here, and it should correspond to these two values. So let's do that. So data analysis, regression. Fortunately, Excel has remembered what I was analyzing previously. I'm going to change this confidence interval to 99 and then run the regression. It's overwritten what I had there, but if I come down here, the lower and upper ends of the confidence interval that we calculated, that Excel has calculated, are identical to the calculations I did in a slightly more manual way. So that is a 99% confidence interval for B5. Not particularly smooth, but effective.